Hi friends, in the last class we learned V versus I graph Ohm's law graph. Just remember this, that is V versus I graph. In the last video we learned this, that is V versus I graph, where either V is plotted along the x-axis and I is plotted along the y-axis, or I is plotted along the x-axis and V is plotted along the y-axis. Both of them are correct and we will get the 2 marks for your board exam. Okay, so this is V versus I graph. But now today we are going to learn, if there are number of resistors connected in a circuit, then how can you replace them by using a single one resistor? Because nanoscience is now developing day by day. As the nanotechnology develop day by day, so we can easily think this, how can we replace this number of resistors by a single one? So then before we have to learn the combination of the resistors or the electric circuit components. Okay, today we are going to learn this. Now the combination of the resistors, there are two types of combination of the resistors only for the board exam. That is, the first one is the series combination and the second one is the parallel combination. What are these? The series combination. Series combination. Series combination means this is also called the linear combination. One by one, like a chain, like a chain. The series combination is similar. If we consider the series combination of the resistors, then this is one resistor, that is R1. This is the starting point A. This is the end point of the R1B. Now another one resistor is connected across the B and D, that is R2, and then another one resistor is connected one by one. That means linearly the resistors are connected, R1, R2 and R3 and so on. Similarly, other electrical circuit components like electric bulb or the electric cell may be connected in this way. This is the series combination of the resistors, because here the resistance R1, R2 and R3 are connected. If we use the electric cell, this will be the series combination of electric cell. Another one combination is also here, where the electric circuit components are connected across the two fixed point, parallel combination. This is the parallel combination. They are connected across the two fixed point. Let the point be A and another one fixed point be B. This is the R2 and R2 resistor. This is R1 resistor, R1 and another one resistors R3. This is R3. Here these three resistors are connected across the two fixed points, that is the point starting point A and the end point B. So across these two fixed points the resistors are connected. If the electric cells or other electrical circuit components are connected in this way, they are also considered to be the parallel combination of like electric cell, the electric bulb, etc. So these are the mainly two combinations. Sometimes we see the mixed combination for the numerical problem. To solve the numerical, later we will learn this mixed combination of the resistors. Mainly in our board exam, there are in Madhyamik level up to the series combination and parallel combination of resistors here. But how can you replace these three resistors 1, 2, 3, R1, R2 and R3 by a single resistor? Or in this combination, parallel combination, how can you replace these R1, R2 and R3 connected in parallel combination by a single resistor without disturbing the potential difference or electric current? So first you have to just keep in mind that the either electric current or the potential difference should be maintained. That means remain constant, but we can replace these resistors by a single resistor, then this single resistor is called equivalent resistor, because the resistor behaves, works by the three resistor R1 and R2 and R3 connected in a combination. That's why this is called the equivalent resistance. In series combination, the equivalent resistance, equivalent resistance, equivalent resistance. So equivalent resistance is the resistance or the resistance offered by a particular resistor without altering the potential difference and the electric current, instead of two or more resistors connected in either series or in parallel combination. Okay, so what will be the value of it? Now the equivalent resistance we can calculate for series combination. For series combination, what happened for the series combination equivalent resistance? Let us consider this R1 and R2 and R3. Let us this, there are three resistors R1, this is R2, and this is R3. Okay, this is point A, B, this is R2, this is C, and this is the point D, this is R3. Now it is connected with an electric cell. Let this is be the electric cell, and across this is the combination of the resistor in series. Let us consider the electric current flows through the wire, that is be capital I, be the electric current. Okay, we can connect an electric switch also here. So for this resistor VA, as electric current flows from A to B, VA minus VB, this is equal I R1. Similarly, VB minus VC, this is equal I R2, and VC minus VD, this is equal I R3. These are written by using the Ohm's law. From Ohm's law, we can write this from Ohm's law. So together, if we just sum over this, then what happen? Then VB cancel, VC cancel, only VA minus VD, this is equal I common, this is R1 plus R2 plus R3 plus R3. Okay, now the resistors, combination of these three resistors R1, R2 and R3 is replaced by a single resistor across the AD. This is the single resistor across the AD. Okay, with the same battery, same electric source, that is the same electric source. Now it is replaced by this, that is the R only. R is the equivalent resistance. So here R is the equivalent resistance because the electric current remains same I without altering the electric current. Now from this we can write, this is the number equation 1. So from this, from Ohm's law, for this circuit, from Ohm's law, by using this we can write VA minus VD, this is equal I R. Now equation number 2. As the electric current here, the same electric current flows, the potential difference is maintained here. So we can write this as the I capital R from equation 1 and 2 equal I R1 plus R2 plus R3, because three resistors are connected here. The result shows that the equivalent resistance will be the algebraic sum of the resistors connected in series combination. Okay, if there are n number of resistors connected in the series combination, then what happen? For n number of resistors, then what happen? Then we can write this capital R, this is equal equivalent resistance equal R1 plus R2 plus R3 plus dot dot plus up to Rn. That means this is the algebraic sum of the resistors. Similarly, we can calculate this by the parallel combination of the resistors. Here the parallel combination of circuit is given. Now we can write this. Calculate the parallel equivalent resistance of the resistors connected in the parallel combination. Let us consider this is the parallel combination of the resistor and the battery is here. Now what happened? Now for this, now I electric current flows through the circuit, and through this R1, that is I1, through the R2, that is I2, and through the R3, that is I3 is the electric current. That means the total electric current I flows through the circuit through the resistance R1 I1 plus I2 for the second R2 resistor, and for the R3 that is equal I3. This is the branching of the or the electric current divides into three parts. So by using the Ohm's law, from Ohm's law we can write this. From Ohm's law we can write this V equal IR, or as the electric two terminals are fixed, so we can write VA minus VD, that is equal V, this is equal I R1, or I1 equal V by R1, V by R1. Similarly we can write I2 equal V by R2, and I3 equal V by R3. Okay, and now I equal I1 plus I2 plus I3. This is equal V common 1 by R1 plus 1 by R2 plus 1 by R3. Now instead of these three resistors R1, R2 and R3 connected in parallel combination, here we use the single resistor. And then our circuit becomes this. Across the 2 point A and B, now the resistors are connected through which the I electric current flows. Now what happened for this? That is the R prime. So R prime here is the equivalent resistance. Now for this again we use the Ohm's law. Then we get in case of the by using the Ohm's law for this, from Ohm's law we write I equal here V by capital R prime. By comparing this equation number 1 and this equation number 2 here, therefore we can write V by R1 equal V into 1 by R1 plus 1 by R2 plus 1 by R3. The result shows that the R prime 1 by R prime, this is equal 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, then what happens? If n number of resistors are connected in parallel combination, then the result will be for n number of resistors. For n number of resistors. For n number of resistors, 1 by R prime, this is equal 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 1 by Rn in parallel combination. Okay, now if the two resistors are connected in parallel combination, then what happens? Then the equivalent resistance for the two resistors connected in parallel combination, that is frequently asked in the Madhyamik exam, board exam, CBSE, ICSE, in all board exam, very frequently asked question. Two resistors, 2 ohm and 4 ohm connected in parallel combination, what will be their equivalent resistance? Then the equivalent resistance will be for the parallel combination of two resistors R1 parallel R2. For this combination, equivalent resistance will be the product of the two resistors R1 into R2 divided by their sum, R1 plus R2. In board exam, very commonly asked, very frequently asked question for the parallel combination of the resistors connected in parallel combination, the equivalent resistance. Okay, today up to this. In the next video, we will learn about the numerical problem frequently asked in the board exam. Okay.